Here we find the domain of a given function. This example has appeared in a JEE main exam held on 22nd July 2021 in the afternoon shift. The question is to find the domain of a function, and the function is the quotient of two inverse trigonometric functions. The problem is, if the domain of the function f of x is equal to, it's a quotient of two functions, the numerator cos inverse under the square root of x square minus x plus 1 by the denominator under the square root of sine inverse 2x minus 1 by 2 is the interval alpha to beta. It is a semi-open interval, open at alpha end and closed at beta end. Then alpha plus beta is equal to, the four options are given to us. It is known that the domain capital D of y is equal to under the square root of g of x is given by D is equal to the set of all x belongs to R such that g of x greater than or equal to 0. And the domain of sine inverse x is the closed and bounded interval minus 1 to plus 1, and the domain of cos inverse x is also the closed and bounded interval minus 1 to plus 1. Let D1 be the domain of the numerator, that is cos inverse under the square root of x square minus x plus 1. And note that x square minus x plus 1 is equal to x minus 1 by 2 whole square plus 3 by 4. Because it is a square, for all values of x it is positive, plus 3 by 4 is positive, positive plus positive, and it will be greater than or equal to 0 for all x belongs to R. So it is strictly greater than 0. Why? Because it is the minimum value is 3 by 4. So it is now D1 is given by the set of all those x belongs to R such that x square minus x plus 1 greater than or equal to 0, which is this is true for all real numbers. This set will be the whole of the real number, the set of all real numbers. Intersection, the set of x belongs to R such that minus 1 less than or equal to under the square root of x square minus x plus 1 less than or equal to 1, because the domain of cos inverse is the closed and bounded interval minus 1 to plus 1. Now the first set is the whole of R, and the second set is to be found out. Now that is equal to, this is R intersection, the set of x belongs to R, 0 less than or equal to under the square root of x square minus x plus 1 less than or equal to 1. Why minus 1 to 0? Minus 1 O closed and 0 open. Those real numbers are excluded here. It is because, note that under the square root of x square minus x plus 1 is greater than 0 for all x belongs to minus 1 to 0. That is the negative numbers up to minus 1 including minus 1. So, and why it is, since x square minus x plus 1 greater than 1 for all x belongs to this interval minus 1 to 0. So it is greater than 1, therefore it cannot come here. Therefore that part is removed, and this is x belongs to R such that 0 less than or equal to under the square root of x square minus x plus 1 is less than or equal to 1. That's the reason. And R intersection any set is that set is equal to the set x belongs to R 0 less than or equal to under the square root of x square minus x plus 1 less than or equal to 1. Now this is the set of all x belongs to R. X square minus x plus 1 is less than or equal to 1. It's obvious reasons. And this will be 1 cancels, and you will get the set of all those real numbers x. So x into x minus 1 less than or equal to 0. That is the set of all those real numbers x belongs to R, 0 less than or equal to x less than or equal to 1. That is the closed and bounded interval 0 to 1. Therefore, the domain of cos inverse under the square root of x square minus x plus 1 is the closed and bounded interval 0 to 1. Now we will find the domain of the denominator. Let D2 be the domain of under the square root of sine inverse 2x minus 1 by 2. That is equal to the set of all those x belongs to R sine inverse of 2x minus 1 by 2 greater than or equal to 0. It is because it is under the square root. Intersection the set of all x belongs to R minus 1 less than or equal to 2x minus 1 by 2 less than or equal to 1, because the domain of sine inverse is sine inverse x is the closed and bounded interval minus 1 to plus 1. Now, this is equal to the set of all x belongs to R, 0 less than or equal to sine inverse of 2x minus 1 by 2 less than or equal to 1. This is less than or equal to 1 because the maximum value of sine inverse x is 1 plus 1. So that is why 0 less than or equal to sine inverse of this one is less than or equal to the maximum value that what it can take, that is 1. It is intersection of the set of all x belongs to R, and you have multiplied the inequality throughout by plus 2, and the inequality is not get disturbed because it is plus, you have multiplied by a positive number. So this is equal to the set of all x belongs to R, and this is 0 is sine inverse 0 less than or equal to sine inverse of this is less than or equal to 1 is sine inverse of pi by 2. Take the sine throughout, and we get the the set of all x belongs to R 0 less than or equal to 2x minus 1 by 2 less than or equal to pi by 2, and it is the set of all those x belongs to R. You add plus 1 throughout in this inequality, you will get this inequality, and this is equal to this first set is the closed and bounded interval 1 by 2 to pi plus 1 upon 2. Intersection the set of all those x belongs to R, minus 1 by 2 less than or equal to x less than or equal to 3 by 2, because you divide throughout by 2, and we'll get this is equal to the closed and bounded interval 1 by 2 to pi plus 1 upon 2 intersection minus 1 by 2 to 3 by 2 closed and bounded interval. When taken the intersection, you will get the closed and bounded interval 1 by 2 comma 3 by 2. Now, since the square root of sine inverse of 2x minus 1 by 2 is in the denominator, we take d2 star as the first one in the first set. It is greater than 0 only we have to take, because is equal to 0 uh, is undefined because it is sitting in the denominator. Intersection the same set as above, and we will get the same answers, except that minus 1 by 2 closed and bounded interval will become semi open, 1 by 2 to 1 by 2 open, 1 by 2 to pi plus 1 by 2 closed. So that is the one. The second is as it is, and you will get the intersection of these two is the open at 1 by 2 to 3 by 2 closed. This is semi-open interval you will get. Now, the domain of the given function f of x is d1 intersection d2 star, and d1 is the closed and bounded interval 0 to 1 intersection, d2 star is the semi-open interval 1 by 2 to 3 by 2 open at 1 by 2 end. The intersection, when we take it, it is the intersection is given by a semi-open interval open at 1 by 2 and closed at 1 end. It is 1 by 2 to 1, and the semi-open and it's open at 1 by 2 end, and it is equal to alpha comma beta, and semi-open interval open at alpha end. And we have to compute alpha plus beta, and alpha is 1 by 2, beta is 1, and alpha plus beta will be equal to 3 by 2. Let's look at the options. In the given options, our answer 3 by 2 appears again as the option 4. Therefore, our answer for this question is option 4. That is the discussion of the finding of the domain of a given function, where the given function is the quotient of two inverse trigonometric functions. I hope that you have understood the method of finding the domain. I wish you all the best. Thank you.